All right, so this is a classic example of do you know signs and directionality, right? So what does it say? It says we take some substances and we put them in here, and when we put it in there, it gets very cold, right? So brr, cold, right? All of a sudden, this guy here turns cold. So what does that tell you? That tells you that the heat is coming from the outside and in, right? Because you feel that it's cold, which means that it's sucking heat away. It's pulling heat in. Again, if you were to feel something and it feels hot, then that's an exothermic. This, you feel it, it feels cold. That must mean that it is an endothermic reaction. So this is an endothermic reaction. Kind of seems counterintuitive, but it's not. You are measuring what's happening in the reaction by seeing what happens to the surroundings. So you are measuring the system by measuring the surroundings and knowing that whatever happens to the surroundings, the opposite has to be happening to the system. So if you are observing cold, that must mean that the energy of the system is gaining the heat because you are losing the heat because you are observing the cold. So it must be endothermic. And if you are endothermic, that must mean that the bonds that are required to break, because remember, if you are breaking things, you have to break all of these. And then over here, you have to make all of these bonds. And if you end up with an endothermic reaction, that means your delta H is positive. It's endothermic. And so the ones that you have to break have to be bigger than the ones that you make, which have to be smaller, because again, using bond energies, it's reactants minus products. So this reactants here has to be a big number so that we can subtract a smaller number on the products and end up then with a positive value, which is endothermic. So for endothermic reactions, ones that feel cold, these are ones where it requires more energy to break the bonds than you get out of it for making the bonds. If it was an exothermic reaction, then it requires less energy to break the bonds than it does for the bonds that you have made, which is why it would be the reverse of this and therefore negative.